Hi everyone, I'm Adrienne Decker, and together with Monica, my co-author Monica McGill, we're going to be presenting our paper on tools, languages, and environments used in primary and secondary computing education. Next slide. So first, this work is funded by the U.S. National Science Foundation, and we thank them for their funding to help us do this project. Next slide. So anyone who has taught computing education knows that one of the burning questions that exists within the community has always been, what tool is the best? What tool should I use? What is everybody else using? Is mine good? And if you're a member of the 60 members mailing list, you can think back to numerous discussions that have worked with this issue and sort of lengthy debates on that. With the explosion of computing in K-12 schools or anything that's before college, this is the same question. It's sort of what works in that area as opposed to sort of where the conversation typically was, which is what works in a post-secondary institution. Next slide. So for us, we were interested in finding an answer to this. What tools, languages, environments are being used in those classrooms, and at what frequency? And in what frequency are they being reported about in the literature? Next slide. So we started looking to see if anyone had done a study like this before. We found quite a bit of work at the post-secondary level, including a previous IDISI working group that was not looking specifically for tools, languages, environments, but did a whole systematic study on introductory programming in the literature. And a section of this report has information about what tools and languages are being used. The census of Australian universities that was repeated in 2001, 3, 10, 13, 16 is a huge piece of work that details what tools and languages and programming environments are being used in Australia across all of that time. But that was one of the most comprehensive ones. We were looking at primary and secondary education, which there isn't a similar census of published that we could find, but Grover and P have an interesting paper about computational thinking in K-12. And in that paper, it's an overview of computational thinking, but there is a section that includes what tools can be used to support computational thinking. All except the census list tools, but they don't tell us anything about frequency of usage or how many people are using them. So we felt that we needed to do a bit more. Next slide. The first thing that struck us is that we needed a good definition of tools, languages, and environments. And it turns out we don't really have a standardized definition of what all of those things mean. And things are a bit fuzzy. So for example, Scratch, which we heard about in the first presentation, is that a language? Is it an environment? Which is it, right? Where would you classify it? Is it both? Does it need to be classified in one or the other? What about physical manipulatives that come up a lot in primary and secondary classrooms? Those are tools and part of the environment that we use to teach computing. They need to somehow be in a classification. So for our study, our working definition is that we included any formal materials that have been studied in research studies or mentioned in experience reports as part of the overall student experience when learning computing. Next slide. Luckily for us to research this question, we had a rich data set that's housed in csedresearch.org that currently encompasses over 600 papers, I believe, in computing education that were published in computing education venues. This study looked at papers from 2012 to 2018 inclusive, and we were looking at the count and percentage of TLEs that were mentioned in the papers across formal or informal environments, if it was used in professional development. We were looked at people who studied students, either research studies or if they were explaining experience reports. And we were also interested in what countries the students were in and what tools were being used across countries. Next slide.
All right, so a couple of things before I go into the results. One is that this data is only descriptive, but it was actually first part of a larger study. And like Adrienne mentioned, we did not separate the tool environments. That got to be very messy very quick early on when we tried to do that, as she mentioned. And then we classify them as both research papers or experience reports. And we did our own classification on this. We've been doing this over the last few years. So I'm going to show you combined and then also separate. And then more than one tool, as you know, in studies may be mentioned. If you're running a summer camp, maybe you're using 2 or 3 tools, so those are added, each of those are added to our count. So on the left here, you see the actual number of articles. So mentions in articles, I should say. There's 605, and you can see Scratch is on top, with garnering 14% of that space. And over on the right, we also looked at where people mentioned, sometimes they don't always mention N, but the number of participants in the study or the experience reports, we counted that as well. So you can see for number of learners in research and experience reports, including students and teachers, we got up to 116,000 represented in Scratch. And then you can see the rest of the tools and languages and environments there. Okay, again, this is research and experience. This is only primary and secondary students. And again, we're seeing, and I'm not going to mention, I'm only going to highlight a few things here. Scratch is on top again. No surprise to us. And then Java App Inventor. And then over on the right, we're looking at the number of learners. And you can see, again, up at the top, 116,000 plus for Scratch. Agent sheets and agent cubes actually came up very high on several of the studies as well. All right, this is just research studies. So we've stripped out the experience reports and looking at, again, primary and secondary students only. On the left, we have the article account. So Scratch has 45 mentions, and then App Inventor CS Unplugged. So you can see CS Unplugged, we're counting that as a TLE because it is a formal environment for teaching. Alice, and then some of the other ones you see here on the left. And on the right, then we have the actual number of learners again. So Scratch, the number for Scratch is a little bit lower than including the experience reports. So many more are including them in the experience reports, but it still shows up as number one. All right, and then the next one is experience reports. So primary and secondary students only. Again, on the left is the article account. So again, Scratch is on top. And then followed by Java, Python, Arduino. And I'll mention here too, obviously the curriculum is changing. Typically it was only in high school and now it's going more and more K through 8. So we expect these rankings to change over time as well. Over on the right, again, we have Scratch on top. And the Beaver's challenge is interesting as well. So we can consider that an environment as well. All right, on the left for this one is the experience reports. And we didn't include research here because there were so few research papers with that were mentioning PD in this time frame. So we've got on the left, Scratch again, but the number of papers and number of mentions is actually a lot lower than students. Again, we're seeing that shift over in the data set that we're going more from students to a lot more teacher papers being put out and accepted to these venues. And then on the right, we have again Scratch and again CS Unplugged, which is very high as well. Right, Adrienne.
So what we can gather from what we were able to do with our descriptive statistics is that we're confirming the list that Grover and P gave us in their list of tools that could be used for computational thinking. We've definitely confirmed that Scratch is currently the most vetted TLE across all of the articles that we have in the data set, which includes professional development for teachers. And it also confirms a lot of the lists that are available through curriculum providers and things like the CSTA of what tools are available for K through 12. So these lists are being used by those people who are using computing education in their classrooms. Important limitation is the fact that the data that's in the research papers and experience reports represent the papers that we have curated in csedresearch.org, which for this study, it was 510 candidate articles, but it certainly doesn't represent the corpus of all publishing that's going on in the world about computing education. Next slide. As with any good study, it's left us with more questions than answers. We're interested in knowing if we have the right tools, languages, and environments for pre-college computing for the standards that the students need to meet. Are there gaps? Are there tools that don't help us teach to the standards that we may need? And that's sort of one of the next steps here. We know what the tools are, what are they covering? And the work led us to the idea that what we don't have is a current and comprehensive updated taxonomy for classifying TLEs, particularly when we're looking at tools that dip into the pre-college space. So it led us to creating such a taxonomy, and we just got word that the paper that describes the taxonomy that we've developed has been accepted at ICER 2020, and we'll be presenting that work in August. And I think we are out of time based on my clock. So thank you, and questions.
Thank